Hello people. In this video, I'm gonna try to go through some things that Unreal Engine 5 and 5.1 added and just recently I started playing with. In order to do that, I will try to do an exercise that it's something that it is the classic exercise of problem solving in rigging, where, for example, a software or a DCC like Maya is not easily solvable unless you use something called script jobs or Python scripting that allows you to run live or offline code in order to address certain things that this setup requires. While in Unreal, because of the new stuff that they added, is actually quite straightforward. Now, you can see here that the exercise is actually the rig of a Rubik's Cube. And this rig is really not that special in Maya. There is a bunch of geometries, and these geometries are just cubes. And then if I move, each little cube is skinned to a joint. Okay. So ideally, we would like to provide the animator with a control interface that allows us to manipulate the Rubik's Cube in the way you expect it to manipulate. But what is the problem? Now, at a first attempt, you could simply say, okay, I want, these joints, these joints, these joints. I'm going to quickly regroup them. Okay, now they live in a single group, and then we can add a simple control that allows us to rotate that, right? And this seems, if we do this on this side, we could do the similar thing. But you can see that the problem now is that when I rotate this object by 90 degrees, this joint up here are not the same joints that they were when they were up here. And this is the classic problem of space switching, meaning that if I now were to rotate this control here, let me just group these as well. It looks like it's working, but because I was going back to the original position. So if I offset these once again, it means that the parent space of these joints, or whatever is driving these joints, needs to change dynamically, or not dynamically in Maya case, offline. The parent of these joints needs to change depending on in which rotation they are performing, and in which quadrant of this cube they live. And this is the classic problem. The way you would solve this in a software like Maya is that you would set up a very complicated rig with, I wouldn't say complicated, but with a high level of depth in terms of hierarchy, and with a bunch of space switching groups. And the way you would do that is that you would have, once I rotate here, you would have an animator running a button that basically performs a space switch in place, preserving all the offsets. And now once the animator is ready to manipulate the top row, it would do, it would constrain the top joints with something else. And this is something that you can perform with a Python script, but we'll see. So basically doing that, you see I just grouped it. But, it requires Python scripting in Maya. This is totally a rig that you can do. Another way in Maya that you can solve it, it's by having some sort of script jobs that allow you to query at runtime and run code at runtime depending on certain conditions. But I always stay away from script jobs simply because I had bad experience when it comes to referencing rigs. Anyway, so this is the problem. And this exercise here allows me to talk about two new things that Unreal has introduced. Now let's go back into Unreal. You can see that now, I have this amazing skeletal mesh in Unreal. And one nice thing I've noticed, I think these joints are matching now the visuals of Maya. Maybe it was always like this, but I've been away from Unreal for a bit due to work stuff. So it could be that this has always been like that. I don't really remember. So Okay, so what are these things that I want to talk about? These things, the first one is they added the spawn transform control, meaning that you can programmatically spawn and generate controls on the fly based on certain rules in the construction event. Oh, they renamed the setup event construction event, and probably to have parity with the blueprinting, the construction script, etc. So, okay, what is spawning transfer control? By the way, this is the full setup, and we're gonna go through it. It looks complicated, but really is not. It's pretty much copy and paste of the same function over and over again. So the spawn control, you can see that this rig here does not have any controls. And now you can always do a new control and place the control whatever you want. Programmatically you can place the control based on a certain joint position. We've seen that in the previous videos. But this is not what we're going to do today. What we're going to do today is that we will create programmatically the control itself, not just placing it. And the cool thing about it is that it means that if you are smart enough with the naming convention of the joints or whatever input, and you're smart enough on building the rig, you can have a control rig that adapts itself and adds or removes control rig structures on the go, depending on the skeletal mesh. And this is quite powerful. So let's start by the simple way. And let's take a random joint. I'm going to get this bone. And the way you do it is type spawn control. I want the spawn control to have the initial value of the bone. And then I'm going to put execute. And you can see that suddenly there's a brand new control here that has spawned there. It's this red sphere here. And it popped in the same position of this joint. If I were to change this to 1 and compile again, it would be somewhere else, probably where joint 1 is, which I have no idea where that guy is. There it is, here. So this joint 1. Now, of course, the spawn control comes with a, we can call it whatever control, and it will be renamed like that. Now, of course, immediately what you can do is, rather than doing it on a bone, you can do it on a bunch of things. For example, I can select all the controls, create an 8-item array. We can loop through it for each element of the control. I want to take the name of the control. Oh, sorry, the name of the bone. I want to say replace. And if I find something, in this case is underscore joint, I can add Mamma Mia. This is just string manipulation. We went through this a bunch of times. Now what I can do is loop through those controls, get the transform, loop through those bones, sorry, transform initial value, and then execute here. So what I expect now is to have a bunch of controls. They're all living inside, are snapped to each joints. And you can see that the spawn controls have a different color. One cool thing that you can do is that you can apply an initial color and transform to the shape of it, meaning that you can have, you can move all of them by 5 units, or you can turn them, all of them, into something like, you can change the shape to be a box thick. See? And now I'm going to change the scale to be 1.2 everywhere. And of course, all these attributes, you can do whatever you want with them. You can create rules to generate these attributes. And I found this extremely interesting because it allows you to basically create pretty much a procedural rig. Because the rigs that rebuilds itself based on the input skeleton hierarchy or whatever. Now, one cool trick I found is that this is a very nice way also to generate, let's say you don't want to have a procedural rig, but you want to have something to start with that is very easy to generate. Well, in this case, it would have been, a little bit of a pain to go through and create these controls manually and then programmatically snap them. But one thing you can do is like you can create them like this. And then what you can do is you can copy and you can paste them. So what happens is that it creates the controls normally, which means now if I remove the construction event that generates the control, I'm only left with these controls. And this is something that you could do it yourself manually or this way. So you're done basically in placing the controls. I found this really useful in another scenario where you want to snap to generate loads and loads of controls, but basically it's a really tedious task to just generate, duplicate. So what you can do is generate them procedurally, then copy and paste them, and they are baked now. This event here does not do anything to them anymore. Okay, so let's jump into the actual example. And let's see the final result, because the next thing we're going to talk about is dynamic hierarchy, which is going to try to solve exactly what we were talking about. Now, let me get rid of all this stuff here I just created. Okay, brilliant. So let me turn off the bones. And this is the final rig. And the final rig, it's very simple. It has, a main transform. And then it has these controls that you can rotate. But you see that without me doing anything, basically it's dynamically changing the hierarchy depending on which control I'm moving. And this is something that is not easily achievable, as I said, in Maya. So effectively, this allows us to rig something by dynamically changing the hierarchy. And you can see that is actually happening here. Let me show you overall how this looks. We have 6 controls, 1 per face. See what happens when I rotate this. You can see that something is going under face B. If I select face D, something is going under there. So how does this thing work? So we touched upon spawning controls. On top of those spawning controls, there is 1 control per cube. And in reality, what I'm doing is that I'm not just spawning at control, but I'm spawning a null. It's not really necessary for this setup, but I like to keep my controls under a null in case I want to use the null for something like dynamics or etc. So you can see that if I compile this again, the structure here is that there is a minikube null within, and inside there is a minikube control, which I have hidden, by the way, by default. So so basically, this is what it would, what it would look like. You necessarily don't need the null or the control. You can use one or the other. Now, on top of that, I'm also spawning the controls. These spheres are basically spawned based on certain specific bones. For example, the sphere is generated on top of this position, and then its shape and transform are moved above. So you can see that if I select this sphere, is always like on top of that. So there is nothing else going on here. The sphere is basically the position of this joint, which I get the transform of a bone, and I say spawn control there. So once the loop is ended, this is the loop that goes through all the joints, and it generates 1 null and 1 control per minikube or per joint. And then after that, I'm building the 6 faces. So you see this 1, 2, 3, 4, 5, 6. And these are these spheres. And the sphere's position, again, it's the joint position plus an offset. And the offset is just in the shape, as I shown before. So this is the construction event, which I'm going to move up here. Now, let's see what happens in the fun bit, the forward solve. So if I remove the first bit, which is the most interesting one, at the very end, you can see that I'm looping through each joint and getting the list of all the joints, and I'm generating a string that substitutes the word joint with controls through all the joints, and then I'm simply project a new parent, it's a parent constraint of that control to the bone. So what this setup means, you guys should be really familiar with this as you follow the other training videos. This is basically connects the control, and by control I mean this thing, to, in this case, minikube 25 control will move through project new parent minikube 25 joint. What it means is that when I move this control here, the joint will move per se. Okay, so this is what it would happen, and this happens at the very end. But what happens in the first part of the sequence, I think it's way more interesting, because this is where we finally touch upon the dynamic hierarchy. Let me build that again. Let me hide the bones. So just double checking that everything still works. Okay, so what's going on here is that I'm looping through everything that it has a name underscore null and that is of type null. So what this list represents is basically all the parents of my controls. And remember, the controls in the end are what are moving the joints. Okay, so I have basically this item here, this list, it's all of these items here. I'm looping through them. And basically what I'm doing is I'm using this node that says get interaction. So this node here, it's pretty damn good because it returns a list of items that the user is interacting with. And in this specific case, I'm saying, give me the list of things that the user is rotating. And these items are dynamically generated. And this would contain a list of objects that the user is currently rotating. Now, because it's a Rubik cube, I'm expecting the user to manipulate only one thing at a time. So what I'd always do is that I'm getting the first element of this array, and we'll see what that does. So I'm looping through each of the nulls. I'm saying, is it something like, is the user rotating something? Yes, it is. So what do I want to do with that information? Well, I want to know which object is rotating, because remember, I don't know exactly which object the user has selected, so I'm checking it. So if the user clicks here and starts rotating, this list would be a list of one item. I take the first item anyway, and I'm checking its name. If the name is face A, then what I do is that I'm checking that the value of the null, and remember, the null is snapped exactly on top of the bone, so it has the same exact coordinates. So what I'm saying is that, is the translate x nearly equal to -10? And what this gives me is basically a quick way to select joints that are living on the same plane. Okay, so in this case, I'm selecting, let's say, -10 for x. So you can see that if I pick these joints, they all share the same coordinate system, and they all share the same x value. Meaning that if the control is face A, I want to be able to select all these joints. Sorry, I'm looking at this. Apologies. So if the user is selecting this, what I'm interested in is knowing which joints lives in this position. And remember, these joints can change. That's why I need to check their value. And this node is quite powerful because it tells you if the coordinate is nearly equal with a tolerance to that value. From there, I'm saying, is it? Then cool. Then for each of those elements we have selected that have this condition satisfied, then switch parent. And what this does is basically literally parenting, dynamically parenting these dynamically generated nulls and controls under whatever I specify here. So this element, this object here is nothing else than I'm saying basically parent the nulls that satisfy this condition under this control. In fact, you can see here that if my control is face A and the user is rotating it, parent the controls that satisfy, or the nulls that satisfy the condition underneath it. After that, connect all the joins. The result of this mechanism is basically the user feeling as if, they can manipulate this cube whatever they want. Let's see what happens now. I have face A control. You will see that if I select face B, it would check, I want to check this, and they need to satisfy to have the Z axis being almost equals to 10, which happens to be the top row. Okay, so what it means is that 3 of these nulls will suddenly move within face B, and the other, so the three things that are currently shared and they sit underneath here, they will jump into face B, as well as the remaining 6. Let's try to rotate it, and you can see that now this list, instead of being 9 objects, is just 6, because 3 of them jumped into this other position, and so on. So this you can see now that we have again 3 shared things here, 3 shared things here. So if I start rotating, let's see face D. No, sorry, what is this? This is face C, sorry. You can see that now it has the controls. And you can see that the hierarchy is dynamically changing. To do this in a standard DCC application, it would have been like a matter of Python, tears, sadness, but in Unreal, it's fairly simple. And this is all it takes. This, I know if you look at the graph like this, it's confusing, but this part is the same. It's always the same thing, just for different controls. And this line here is always the same. It's the same check, is the same equals. I only had to change the values because I'm interested in different positions of the joints. But conceptually, it's always the same. So it's 1, 2, 3, 4, 5, 6, which represents the amount of faces of this object. I hope this was clear. This is extremely powerful, and I can't wait to try it more.